All right, everyone, back to mechanics of materials, and we're gonna talk right now about Mohr circle for plane stress, and Mohr circle is just a graphical tool for these stress transformation equations that are here, and something that Otto Mohr, the German civil engineer, came up with a long time ago, and but it really is just a graphical tool, a visual way to see how to go from one state of stress to another. And usually what you're given is a state of stress here, that you calculated from using all your stress equations like my over I or VQ over IT, all the shear stress equation, whatever, right? You got the state of stress at a point in a structure, and now you want to find this either the state of stress at a new angle of orientation, the principal stresses and orientations, or maybe the maximum in-plane shear stresses, and inevitably it requires that you draw a representative element in that new orientation. And Mohr circle is a nice way to visualize all this and come up with, and that way you don't have to memorize any equations or anything. And if you understand it, really you can transform any state of stress from any angle of orientation to another one. But you really, the principal stresses and maximum in-plane stresses, those maxes are important to us because they'll tell us things about like cracking behavior of a structure or just how to design for a specific state of stress. So here, normally we have this given state of stress here that we calculated, and let's talk about how we would construct Mohr circle from that. So here, let's going down over here. We've got this state of stress, and I've got, let's say I draw here some stress value, some normal stress here, some shear stress condition that causes this, and this. Okay, and then some stress, some normal stress here and here, just to make sure that we have equilibrium. And one thing I want you to note is that, hey, I didn't establish any coordinate system. I didn't label anything sigma x, sigma y. Okay, these are essentially just numbers indicating a state of stress at this representative volume element. And really, the first thing that you need to do here is one is establish a coordinate system. Okay, establish a coordinate system for your given state of stress. Okay, establish this coordinate system. So here we'll start off simple. We'll do a basic, and this is the way you should normally do it, right? But here is like here is I'll call this my plus x direction, this my plus y. Okay, and here then now I can assign labels to each of these. This normal stress component is, this is a normal stress in the x direction, so I will call this sigma x. And then here, this is my normal stress in the y direction here. And here, this, based on my coordinate system, this shear stress is a positive shear stress because it's on the plus x face in the plus y direction. And, I can look at the same thing here, plus y face in the plus y direction. Positive times a positive is a positive. Here, it's a negative y face in the negative x direction. Negative times a negative is a positive. So this is, according to my coordinate system, this is a positive shear stress condition. So I established this coordinate system. Two, two is I want to determine the center of Mohr's circle. And that center of Mohr's circle, is this center point is essentially sigma average comma 0 in a sigma tau coordinate system, okay, that you're going to draw for Mohr's circle. But the center is just the average stress. So the sigma average is just sigma x plus sigma y divided by 2 comma 0. And it's, and in plane stress and even 3D stress, this is, it's always 0. Okay, the center of the circle always rests on the sigma axis. So now what we want to do is, now that we know the point for the center, we want to draw the coordinate system, draw a sigma tau coordinate system. Okay, coordinate system, and draw the center point. Okay, the center point. So here, if I'm doing that here, okay, once I've established my coordinate system, I've got this here. I'm going to draw my coordinate system. Let's say I have here let's do here, right here, okay? And normally what you do is plus sigma to the right. Now, depending on what kind of convention you're using, whatever, what book you're using, or however you want to look at this, I'm a big fan of using this plus tau in the downward axis. Okay, and the reason is because when you rotate, if you will, a Mohr circle, and we'll get to this in a little bit, but when you rotate a Mohr circle clockwise, what you want to do is so that that we want that transformation to be 1 to 1, if you will. Okay. So, but if you what I want is that if I rotate clockwise in Mohr circle, I want to rotate clockwise in my stress state. Okay. And so here I've got this this axis drawn. I draw my center point. Here is my center point. Okay, this is my center point, sigma average, comma 0, right here. Okay, and then now the next thing I want to do is I want to draw or locate 1 point on the outer radius, outer radius of that circle, of Mohr's circle. Okay, and this will give me the point that I need so I can draw the circle. But here I've got let's say I've got here, and that outer point, that point A, we'll call it point A, is just sigma x comma tau xy. The values that are up here in this state of stress up here, okay, we just take them directly to this point right here. So this would just be, hey, sigma x, hey, sigma x would be, some number. Let's say it's just the way. Let's make this look kind of real here. Let's say it's like over here, sigma x plus sigma y divided by 2. Let's just say it's over here. Okay, it's some number over here, and in the plus tau xy. So this is point A, uh, point A, point A with sigma x comma tau xy. All right, and so now I've got this. I can draw my circle. I've got this radius, if you will, already set up right here. The radius of it, which I go, oops, okay, which I go like this right here. There's my one arm, and I just swing that all the way around 360 to make a circle. And can I even do this? Let's see. I think I've got something here that's about the same size. See how that works. Oh, shoot! If I had a steadier hand, I would be maybe a professional artist. Oh, snap! That's homeless. All right. Okay, but it's a circle nonetheless. It's a circle, and it will do for us. Okay, it will do. And if you look here, look, check this out. This is sigma average right here, okay? And here is this point right here is this distance is sigma x, and this distance to point A right here is tau xy. Yes, okay? So that means, hey, I know this distance right here. I know that distance is just sigma x minus sigma average. That distance is right about here. That distance right there is sigma average. Right here, that distance right there is sigma x minus sigma average. Okay? And here, this distance right here is tau xy, right? This vertical distance going like this. And I essentially have a triangle. And if I want the radius of this right here, this radius, then I just have to do, for the triangle, Pythagorean theorem, square root of some squares, this radius, which would be, I guess, step 5, calculate the radius. 5, calculate radius right here. And you calculate this radius, and you've got, what is this? This would be sigma x minus sigma average squared plus tau xy squared. Okay, and that's the radius of the circle. That's great, right? And that means once you know the radius of the circle and you know this dimension, you can also calculate this angle right here. Okay, and look at this. The maximum stresses, or the maximum normal stresses, are this point right here, and the minimum would be this one right here. Okay, these two endpoints, and these are our principal stresses, sigma 1, sigma 2, and then our maximum shear stresses would be up here, or up down here. This would be tau max. Okay, sigma 1 being the, anyways, maximum principal stress. And look, and once you know this right here, so the nice thing about this is that this right here, when I look at this circle right here, this line represents right here theta equals 0 degrees, or this original coordinate system, theta equals 0 degrees. And if I want to get to my maximum principal stresses, I go this angle, this angle right here in Mohr's circle. If I rotate, what is this, counterclockwise in Mohr's circle, then I'm going to rotate this, my state of stress, counterclockwise, and that's going to give me a second state of principal stress there. All right, let's see. Hopefully I didn't butcher this too much, but good luck. I'm going to stop here, and then let's do an example problem. That's always